This is Britt Caswell with another video example. In today's lesson, I am actually going to be going through Lesson 1-6, Example 2 in the SavvasRealize Algebra 2 textbook. I have decided to split this example into two. Okay, I already did the try it. I did that first in a separate video. And then now I'm going to go through and do this word problem because it can be a bit intensive. So if you're looking for the try it, please make sure to look out for that other video. So in this example, we have a kid named Malcolm, okay? And Malcolm, he's kind of doing the hustle, all right? He's trying to make money by mowing lawns and walking dogs, all right? So what I'm going to be doing is I'm going to be looking at all these little requirements that he has. These are called constraints, okay? And I'm going to use these constraints or these requirements to help me to narrow down a field of options for him to choose between how many hours he's walking the dog and how many hours he's going to be mowing lawns. Okay? So when I go to do this, when I go to create my equations, I'm going to create kind of a table here. Okay? And on this table, I'm going to put walking dogs and mowing lawns, and then a total. And that's going to help me to create my my equations, okay? Alrighty. So, the first thing that I'm going to check out is I'm going to look at kind of just the whole problem, and I'm going to go through it kind of sentence by sentence, okay? So the first thing I'm going to consider, it says his goal is to earn at least $200 each week, okay? So that's talking about money. So I'm probably going to have some kind of inequality involving money, because our first sentence that we read, that he earns $20 per hour mowing lawns and $10 per hour walking dogs, that's all money, okay? So then it says, but he can also only work a maximum of 20 hours per week. Okay, so this one's going to be a maximum time kind of inequality, okay? And then we have one, it says, Malcolm must spend at least 5 hours per week walking his neighbor's dogs. Okay, so that's a minimum of a dog kind of thing. And then it says, for how many hours should Malcolm work at each job in order to meet his goals? Alright? So I'm going to use these three equations, or these three situations, to help me create a system. So let's start with my money system here, okay? So it says he earns $28 per hour mowing lawns. Okay, so I'm going to call that Y, okay? Now I'm actually going to call the mowing lawns X. That way it matches your example in your book. Okay, so with the mowing lawns, he earns $20 per hour doing it. So my X is the hours spent mowing lawns. So $20 times that X would get me the amount of money he spends, or he makes, mowing them. And $10 per hour is walking dogs. So I'm going to say that is 10Y here. And then it says that he wants to earn at least $200 each week. And it could be a combination between the two. So I'm going to put a 200 here in my total. Now if I am making an equation, I need to go ahead and put some symbols in here, right? So I'm adding together the money from walking the dog and the money from mowing lawns. So I'm going to have a plus here. Now if I want him to earn at least $200 each week, he can earn exactly $200, right? So I'm going to put the little inequality bar for equals. And then to show at least $200, we have to think about whether it should be a greater than symbol or a less than symbol here. Okay? So 200 is the minimum. He can earn more than 200, right? And that would be great. He could earn like $300 and he'd be happy. Okay, so that means that whatever he earns has to be greater than that 200. So that's why my inequality's facing towards the equation. So now let's try with the green one. It says he can only work a maximum of 20 hours per week. Okay, so that's the total number of hours he can work. So however many hours he chooses walking the dogs, plus however many hours he chooses to mow lawns, okay, that has to be less than the 20 hours that he's doing. Okay. Now, can he work for exactly 20 hours? Sure, because it says he can work a maximum of 20 hours. So make sure to put the inequality symbol there. Okay, so here's the maximum amount of time, and it has to be less than or equal to the 20 hours. So then he has an agreement with his neighbor, right? That's the brown sentence. And he says that he needs to spend at least 5 hours per week walking the dogs. Okay, so we know he's at least spending 5 hours here. Now, we don't have anything about mowing lawns in this sentence, so we're not going to put anything there. Okay, it's essentially just a 0. And that 5, or I'm sorry, I put that 5 in the wrong place. That 5 hours, that's his maximum, that's his total, right? So here's his number of hours walking the dog that he's agreed to do for his neighbor, and it's at least 5 hours. Can it be exactly 5 hours? Sure. Those dogs will probably like it. So we're going to put that little line under there to show that it can be equal to. And to show at least, his number of hours can be greater than 5, right? So I'm going to use the greater than symbol to get that right there. So now there's my constraints. Now it is worth noting here that when I go to graph it, I can't have a negative number of hours, right? Like I can't say, oh, Malcolm walked dogs for -3 hours yesterday. That doesn't make sense. So when I go to graph this, I don't actually really need the whole coordinate plane. I'm just going to need the first quadrant, because over here would be negative time mowing lawns, and over here would be negative time walking dogs, and those don't make sense. So most of my graph is going to be right here in the first quadrant. Alright, now with graph paper like this, I'm going to make sure that I have a scale written here. Okay? I'm going to be counting by 2s. That way you know that each box that I pass by is going to count for 2s. So in my last video, I showed you how to graph from standard form. Okay, I said plug in 1 for x, or 0 for x, figure it out. Plug in a 0 for y, figure it out. In this one, I'm going to show you guys how to convert it into slope-intercept form to graph it in the ways you've always learned. Okay. This is also how your textbook does it. So if you guys are looking at your notes in your textbook, you guys will see kind of the same format. So just a reminder, slope-intercept form is y equals mx plus b, where m is my slope and b is the y-intercept. So if I change my equations around, I add, subtract, whatever, and I get it to look like this, I can automatically graph my y-intercept and use my slope to find additional points. Okay. So the first thing that I need to do is I need to solve to get y alone. So I'm going to go ahead and subtract this 20x to the other side of the equal sign. so here my x's cancel, so I get 10y is greater than or equal to, okay, now 20x and 200, those aren't like terms, so I can't combine them. But to put it in slope-intercept form, I need to put the x term first. So I'm going to have a negative 20x first, and then put my plus 200 here at the end. And then my last step to get it in slope-intercept form is I need the y to be alone. Right now it's being multiplied by 10. So to get the y alone, I'm going to divide both sides of the equal sign by 10. Now make sure when you do that you're dividing everything on that right hand side, okay? So here I get y is greater than or equal to negative 20 divided by 10 is negative 2, and then there's the x, and then 200 divided by 10 is 20. Okay, so my first equation is right here. So I said first we graph the y-intercept, which is here at 20. So it's important that I'm counting by 2s, otherwise I'd run out of graph, right? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's right up here at the very tip top. Okay, there's my y-intercept. Now my slope is negative 2. So in terms of these boxes, I can fall 2 and run 1. Okay, so, and I can go further down like this, but we already said we don't need anything below the x-axis, right? Because you can't have a negative time walking dogs. Now my inequality symbol, it says that y is greater than or equal to these values. So I have two choices. I could pick a test point, right? I'd probably pick 0, 0 and see if that works. Or if you have it in this form, the slope-intercept form, anything that's greater than here, or y is greater than, is kind of above the line. So you see we have this line, which I'll go ahead and connect my dots with. And if I were to go about shading that line, the part that's above it would be shading this way. Okay. I'm just going to draw these arrows on here for my shading instead of filling up my graph. And then at the end we'll talk about where it overlaps, okay? So there's my orange line. So now I'm going to go through and I'm going to do that same process but with my green line. Now this one should be a little easier because the coefficients in front of the variables, so the number in front of the letters, is just 1. So it should go fairly quickly. So I have y plus x is less than or equal to 20. So to get y alone, I'm going to subtract x from each side. So here those x's cancel. I have less than or equal to. And 20 doesn't have any x's in it. So these aren't like terms. I can't just squish them together. So I'm going to go ahead and make sure that the x term is first so that I'm in slope-intercept form. So I'm going to put my minus x, and then I'll put the plus 20 next. So on this inequality, okay, my y-intercept, so where it crosses the y-axis, is at 20, which was the same as the orange one, so that's kind of nice. And then it says my slope is negative 1. So in terms of these boxes, I'm going to fall 1 and run 1 on each one. So right here, my green line would kind of follow this path. And I'm going to make sure to use a solid line because it can be equal to. Make sure I try to draw a straight line. Alrighty, so there's my green one. And in terms of shading, it says y is less than or equal to all these. So the less than side would be underneath this line. It would be going that way with my shading with the green. So if I were to shade everything to the right in orange, and then everything to the left in green, Do you guys see that the overlap right now is this space between the two lines? And then our last one is the brown one. The brown one we're kind of excited about because it's a little easy, right? It's just a single variable already solved for. Ooh, it's good stuff. Okay, so y is greater than or equal to 5. Okay, anything with y equals is just a horizontal line, right? Because it doesn't matter what your x value is. And it's going to be a solid line because it can be equal to. So here's 2, 4, 5. So I'm going to have a solid horizontal line right there. Now it says that y is greater than or equal to that 5. So if I were shading for the brown line, I'd be shading up. Okay, so all of my points that are intersecting, right? I came to the left on the green, to the right on the orange, and up on the brown. So this space, this like triangle that's between them, that's my solution set where all my shading would overlap if I were to shade it. Okay, so any point that's inside this yellow is a solution. It would earn him the $200 that he's looking for, but it would also meet his requirements if he's walking if he's trying to, manage his time a little bit. So like I could pick this point here, which is at 8, 8, that's an answer. Okay, I could pick something that's on like this line right here. Okay, so that's 2, 4, 6, 8, 10, 12. So he could do 12 and 5. Alright, so what these ordered pairs are saying, remember the x is the mowing lawns, the time spent mowing lawns, and the y was the time spent walking dogs. So these ordered pairs are describing the amount of times he'd be spending. So he'd be spending 12 hours mowing lawns and 5 hours walking dogs in this point. Or he could spend 6 hours walking dogs, or 7 hours walking dogs. You see how all those points are contained in there? Alrighty, so these kinds of problems, these are pretty common in terms of word problems. So I'm going to try to find a few more examples of them if you're curious to look at them more, but they are very useful problems. We use them a lot in kind of business models when we're trying to figure out how to make the most money. Alrighty, so that's this example, and until next time.